Hi everybody! So in today's video we're going to be talking about how to take the derivative of an inverse function. Now in class we explored the relationship between the derivative of the original function f of x and the derivative of the inverse function. Using that relationship we can establish basically what is a formula that will allow us to get these derivatives. So here's what the formula says. If I have the inverse function of an original, so f inverse or whatever, and I want to find the derivative of that at some specified value, which is usually a y value, then that's going to be equal to 1 over the derivative of the original function at the corresponding x value. Now let's take a second and just think about what this formula actually means. So the beginning of this formula says f with a little -1. We need to remember that this means the inverse of f. Now having this little prime notation here means we're taking the derivative of the inverse of f. The reason that we write a y here is because this is the y value of the original function. So the original point would be x comma y, but because this is the inverse, the inputs are the y values of the original. Now what this formula says is if you want to find this derivative, then you take the derivative of the original and you plug in a certain value. But the number you're plugging in here is the x value of the original. So these two numbers will always be different. Because this number will always be an output value of the original, and this number will always be the corresponding input value of the original. So let's talk about how you would actually use this formula. What would these questions look like, and how would you approach them in an organized way so that reading the problem isn't confusing and we can understand what to do? So problem number 1 says let f be the function defined here. So we've got f of x equals x cubed plus 7x plus 2. If g of x equals f inverse of x, now I want you to stop. This is telling me that g is the inverse of f. So it's telling me I'm dealing with an inverse function relationship. And f of 1 is 10. What this tells me is that in the original function, the point 1 comma 10 is on the function. It also tells me that on the inverse function, the point 10 comma 1 would be on the function because the original and the inverse just switch the x's and the y's. Then, what is the value of g prime of 10? If it's asking me to find the value of g prime, and g is the inverse of f, then it's telling me I need to use this formula. So let's start by copying down what it's asking me to find. The problem is saying find g prime of 10. But I know that g is really the inverse of f, so I can replace g with f inverse. So what this really means is that I'm finding the derivative of the inverse of f at 10. So I'm just replacing g with f prime, because it tells me here that G is equal to F. I'm sorry, I'm replacing G with F inverse because it tells me here that G is equal to F inverse. So I'm just replacing that. Now my formula says that in order to find the derivative of the inverse, I do 1 over the derivative of the original. So I would put F prime at the corresponding x value. So in the original function, this is a y, which I can see here, which means the corresponding x would be the 1, which I can put here. So this is the y, this is the x. Just like here, this is the y, this is the x. They're numbers that are associated with each other, they're related to each other, but they're not the same number. So really, now I just need to find this, 1 over the derivative of f prime, and I plug in 1. So I'm going to take the derivative of f, which I have here, and I'm going to plug in 1. So I'm going to have 1 over, now f prime is going to be 3x squared plus 7, and then that's it. If I plug in 1, I'm going to have 1 over 3 times 1 squared plus 7, which simplifies to 1 over 10. And that would be my final answer. So let's try this again. Let f be the function defined by f of x equals this equation. If f of x equals f inverse of x, I'm sorry, there's a bunch of typos here. If g of x equals f inverse of x and f of 1 equals 7, what is the value of g prime of 7? So let's start by just identifying what we know. We know that there is an inverse relationship between g and f. We also know that on the original function f, the point 1, 7 is the ordered pair that corresponds, which means on the inverse function, the point 7, 1 would be a point. Now, it asks me to find g prime of 7. Since g is really the inverse of f, I'm going to replace the g with f inverse, and I want to take the derivative at 7. Now my formula says this is going to be equal to 1 over the derivative of the original at a different value. This 7 is always the y value of the original, which means the corresponding x value would be 1. You'll notice that these are different numbers because this is a y and this is an x. So now, in order to calculate this, I need to take the derivative of f, which I have here, and plug in the number 1. So the derivative of f would be the derivative of 7x cubed, which is 21x squared. The derivative of natural log cubed would be 3 times the natural log of x squared times the chain, which is 1 over x. Now I would just plug in my number 1. So I would have 1 over, and I would have 21 times 1 squared plus 3 times the natural log of 1 squared times 1 over 1. For those of us who don't remember, the natural log of 1 is actually evaluated to 0. So my simplified answer would be 1 over 21 times 1 squared is just 21 3 times 0 squared is 0, times 1 is still 0. And so I would have 1 over 21 as my answer. Okay, thank you guys so much for watching. Have a wonderful afternoon, and I will see you for some practice.